Hi, in this video, I'll walk through the definition and conditions of a binomial distribution. First, let's talk about the concept of a Bernoulli trial, also known as a binary trial. A Bernoulli trial is a random variable that has exactly two possible outcomes. We call one of them the success, and we call the other one the failure. The probability of success is denoted by the letter P, and the probability of failure is equal to 1 minus P, and sometimes we denote it as a letter Q. So here are some examples of a Bernoulli trial or binary trial. If you randomly guess at a multiple choice exam question with 5 options, then there are 2 possible outcomes. Either you get it correct or you get it incorrect. And I guess most of us would define success as getting it correct. If we define it that way, then the probability of success is P equals 0.2, 1 out of 5. Next example, let's say that you shoot a free throw in basketball. Then either you score or you don't score. So 2 possible outcomes. And now you can sort of tell where the name binary comes from, either one or the other. And we can define success as scoring. By the way, you can define it either way. You can define as scoring as success if you're the person shooting the basketball. If it's the other team shooting the free throw, then in your mind, you think the success is if they don't make it. So in looking at the Bernoulli trial, the word success has no value judgment to it. It's just that there are 2 outcomes, so we choose one of them, we call it success. But anyway, let's say that we define success as scoring. Then there is a probability of success P. We don't know what it is. It is equal to that person's free throw scoring percentage. Okay, some people are really good and they have like an 80% free throw percentage, and some people are not so good and they have a 15% free throw percentage. Whatever that number is, it is the probability P of making a free throw. Next example, if you check a person's blood sugar level to see if they are diabetic. Since you're checking for whether or not a person is diabetic, then there are exactly 2 outcomes. Either they're diabetic or they're not. We can define success as being diabetic. Again, there's no value judgment to it. There are 2 outcomes, just choose one of them and call it success. And in that case, the probability of success is some fixed number P that we don't know that is equal to the proportion of the population that's diabetic. These are examples of trials that are Bernoulli trial. Now let's look at some examples of things that are not Bernoulli trials. Let's say that you're still randomly guessing at a multiple choice exam question with 5 options, but instead of just figuring out whether or not you got it correct or incorrect, you actually keep track of what letters you're using. If that's your variable, then it has 5 possible values. And therefore, it's not binary, it's not Bernoulli. Next example, if you check a person's blood sugar level, but you're not the doctor, you're the lab person, so you just write down the number and you pass it off. Your variable is the number. Well, that numerical value is obviously a whole range of possible outcomes, so no, it's not binary, it's not Bernoulli. Next example, let's say that you check a student's GPA. You ask them, what's your GPA? They give you an answer. Well, since GPA have a whole range of numerical values, it's not Bernoulli, it's not binary. That's the concept of a Bernoulli trial. A binomial experiment is an experiment or procedure where you repeat a fixed number of independent Bernoulli trials. A single trial with 2 outcomes is a Bernoulli trial. You repeat that multiple times independently, and you know how many of them you're doing. That's a binomial experiment or a binomial process. So since independence means the probability doesn't change, you can rewrite this definition in terms of the criteria that are usually taught in a statistics class. First of all, you need a fixed number of trials. a binomial experiment repeats a Bernoulli trial a fixed number of times. And since each trial is Bernoulli, then that means each trial has exactly two possible outcomes. One of them we call the success, and the other we call the failure. And then each trial has to be independent. So in practice, that means either you require that each trial be independent, or you require that there be a fixed probability of success each time. Now, many people teach these as 4 separate criteria, but criteria 3 and 4 are basically the same. If you have independence, you have fixed probability of success. If the probability of success is fixed, by definition, it means the trials are independent. So you can also do it as just 3. Do whatever your professor says, okay? If you're my student, I only require 3 because 3 and 4 are the same, so either or. But if your professor wants 4 conditions all verified separately, do them all separately. Let's take an example. Is this binomial? The college administrator selects a random sample of 200 students and collects data on which high school each student graduated from. So let's go through the conditions one by one. Condition 1, is there a fixed number of trials? For this kind of question, you have to think in your head, what is the definition of each trial? In this case, each trial means checking the high school of one student. And I'm doing it 200 times, so yes, there is a fixed number of trials. The number is 200. Criterion number 2, exactly 2 possible outcomes each trial? If yes, then define which one is success. Well, in this case, you're checking on which high school the student graduated from. So you come up to a student, say, what high school did you graduate from? Then you can tell that no, each trial where you check the high school of each student, you could have multiple possible answers. No, potentially hundreds of possible outcomes. Condition number 2 is not met. Now to condition number 3, are the trials independent, and or if there's success, then is the probability of success fixed at some number p? The answer is yes. The students were randomly selected, and that means there's no dependency between them. The answer is the trials are independent. All right, so we have fixed n. We don't have exactly 2 possible outcomes each trial, and we do have independent trials. We got 2 out of 3. Does that mean it's binomial or 2/3 binomial? And the answer is no. To be binomial, you have to meet all the conditions. You miss any one condition, is not binomial. And therefore, for this problem, the answer is that no, it is not binomial. Next example. Example 2. Laverne plays a game where she rolls a pair of dice and wins if she rolls a double 6. She plays 50 times and records the number of wins. Is this binomial? Let's go through the conditions. Number 1, is there a fixed number of trials? Well, think about what is a trial in this context. In this context, each trial is 1 attempt by Laverne. So each trial is 1 roll of a pair of dice. Each trial is 1 play, and she plays 50 times. So yes, the number of trials is fixed at n equals 50. The letter n is used for the number of trials. Condition number 2. Does each trial have exactly 2 outcomes? And if so, define which one is your success. Yes, we're recording number of wins, so the outcomes are either win or not win. Either get a double 6 or not get a double 6. We can define the success as a win of getting a double 6. Are the trials independent, and or is the probability of success P fixed? Yes, we're rolling dice. That's like a quintessential prototypical independent event. Each roll of the pair of dice is independent, and on top of that, what's the probability of getting double 6? 1 out of 36. the probability is fixed at p equals 1 over 36. So this is binomial. Now, some of you may ask, what happens if I define success the other way around? Wouldn't that change the value of p? Yes, if you define success as losing, then for Laverne, p would be 35 out of 36. But that's okay, because everything got flipped from success to failure and failure to success. Everything got flipped. If you ask a question like, what is the probability that Laverne wins exactly 20 times? Well, that also got flipped into asking, what's the probability that Laverne loses exactly 30 times? So since everything got flipped around, things even out and you come up with the same answer either way you define success. Okay, so don't worry about that. In this video, we don't go through the calculation, but once you get to that point, you should try once. Solve one problem by defining success one way, and then solve the same problem again by defining success the other way. Then you see that everything got flipped, so everything evens out, and you come up with this correct answer, with the same answer. Coming back to this example, we have a binomial situation that involves 50 Bernoulli trials where the probability of success is 1 out of 36. The number 50 and the probability 1 out of 36 uniquely define the binomial distribution. So the notation for this is capital letter B for binomial, open parentheses n, the number of trials, comma, p, the probability of success. So for this particular situation with Laverne and her gambling, the notation is B, open parentheses, 50, comma, 1 out of 36, close parent. Moving on to example 3. A manager meets with independently selected applicants until she can find 10 people with cashier experience. Is this binomial? Let's check the conditions. Condition number 1, is there a fixed number of trials? What's each trial in this case? What is it that the manager is trying? She's trying to go for someone with cashier experience. So each trial is one meeting with an applicant. And is this number fixed? You may be tempted to say 10, but it's not. We don't know how many applicants the manager has to meet with until she can find 10 that have cashier experience. So no, the number of trials is not fixed. So this is not binomial, but let's go on anyway and check the other conditions. Number 2, are there exactly 2 possible outcomes each trial? This one, the answer is yes. Either the person has cashier experience or they don't. And we could define success as someone has cashier experience. Condition number 3, are the trials independent and or is the probability of success fixed at a number p? Yes, independence because each applicant is independent from the other. And yes, the probability of success is fixed. We don't know what it is, but we do know that it's fixed and it is equal to the percent of the people in the applicant pool that have cashier experience. Whatever that percent is, it is our probability P. Last example, is this binomial? Approximately 53% of people who take the driving test at the DMV in San Jose, California pass. Check a random sample of 200 test takers. Condition number 1, is there a fixed number of trials? By now, you should know that each try consists of one test taker going to take the driving test. And we're checking 200 test takers, so yes, we have a fixed number of trials, n equals 200. Number 2, does each trial have exactly 2 possible outcomes? Yes, you take the driving test, you either pass or you don't pass. And we could define success as pass. Moving on to condition 3, are the trials independent and or is there a fixed P? Yes, the trials are independent because test takers, if we take a random sample of them, they are independent. And P is fixed at 0.53. the probability of success, which means passing the driving test, is 53%. So the notation for this binomial distribution is capital B, open parentheses, 200, comma, 0.53, close parent, B, and comma P. All right, let's summarize. The conditions are, number one, is there a fixed number of trials? If yes, then that's our parameter N. Number two, does each trial have exactly two outcomes? Usually yes or no on something. Yes or no on passing a driving test. Yes or no on winning the game of the pair of dice. If the answer is yes, then define which one of the outcomes is your success. You have to make this definition because it could be either. Condition number three, are the trials independent and or is the probability of success fixed? And again, some professors and teachers may require you to do both of these separately as two conditions. And if yes, then you determine the P if the question gives it to you. You need all conditions to be met for the process to be binomial. If any one of them fails, not binomial. If binomial, then the notation is capital B, and the two parameters are N, number of trials, and P, the probability of success. Right? Hope that helps. Thanks for watching. Subscribe for more contents. Bye.